Hi everyone, welcome to Unit 19 of online course on probability distributions. In the last modules, we have discussed some numerical examples with respect to binomial distribution, Poisson distribution. That is, some examples in which we are applying Poisson distribution for finding probabilities of certain events. In continuation of the last module, in this module also we are going to discuss some numerical examples with respect to Poisson distribution. Let us consider the problem. Suppose the probability that a person is killed by lightning in a year is 1 out of 500 million, and that is independent occurrence. Assume that the population in the region is 300 million. Compute probability that 3 or more people will be killed by lightning in the next year. So, this is an example where we can apply Poisson distribution to find the probability of certain event. What is the problem here? Here the problem is, we know from the previous experience, the probability that a person is killed by lightning is approximately 1 out of 500 million. So, that means the probability is very small there, and the population size is given to you. In that region, the population size is 300 million, that is n is very large. So, this is a situation where we can apply Poisson distribution to find probability values. And so, the procedure is to find the value. So, you are given x number of person hit by lightning. So, suppose this is the random variable we are defining, and you are given probability of that is 1 out of 500 million, that is given to you, and the population size is given, that is number is given, it is 300 million. So, population size is 300 million and P is the probability of hitting a person is hit by the lightning is given to you as 1 out of 500 million. So, that is, it is a small value, and it is the size of the population is large. So, use the Poisson approximation. Use the Poisson approximation means you find the value of NP there, that is 300 divided by 500, or that is 3 out divided by 5. And as per the Poisson approximation, this quantity is denoted by lambda, that is lambda is equal to NP, that is 3 divided by 5. So, lambda is equal to 3 divided by 5. And now come to the point. The point is, the problem is what? You have to find the probability of the probability that 3 persons hit by lightning in a particular year. That is, we need probability of x is equal to 3. This is the probability value we require. And by the Poisson probability mass function, probability mass function of the Poisson random variable, we know this is given by e power minus lambda, lambda power x divided by x factorial, where x is any value from 0, 1, 2, etc. and lambda is a positive number. This is the probability mass function of the Poisson random variable. And hence, what is the probability of x is equal to 3? Probability of x is equal to 3 is equal to e power minus lambda. Lambda is already we calculate as 3 by 5. 3 by 5 lambda power x, that is 3 by 5 power x. X is here 3 divided by 3 factorial. So, this is the probability of hitting 3 persons by the lightning in a year in that population, in that region. That is probability of x is equal to 3 is equal to e power minus 3 by 5, 3 by 5 power 3 divided by 3 factorial. And the question, suppose at least 3 persons are hit by that lightning. Suppose we need probability of the lightning is affected by at least 3 persons, at least 3 persons are affected by lightning. Suppose we need this probability, and that is equal to probability that at least 3 persons means x greater or equal to 3. So, probability of x greater or equal to 3 is the probability that at least 3 persons are hit by the lightning, and that is equal to, you can find this value either by taking the summation x is equal to 3 to infinity, or I think it would be better to take the complement of that one, that is 1 minus probability of x less than 3, that is 1 minus probability of x is equal to 0, 1 or 2, and that is 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 2. So, this probability value is the probability of at least 3 persons are hit by the lightning, and in order to find this value, just substitute all the quantities here, that is 1 minus e power probability of x is equal to 0, that means e power minus 3 by 5 plus probability of x is equal to 1, that is e power minus 3 by 5 into 3 by 5 power 1 divided by 1 factorial, that is that itself, and probability of x is equal to 2, that is e power minus 3 by 5, 3 by 5 the whole square divided by 2 factorial. Simplifying this expression and you will get the values, you can calculate the values, and by calculating all these values we have the probability of at least 3 persons hit by the lightning. So, this is a practical problem we are using to find the probability values in the case of a situation regarding affecting the lightning in a region. So, this is an example where we are applying Poisson distribution. You consider another example. Suppose if electricity power failures occur according to a Poisson distribution with an average of 3 failures every 20 weeks, calculate the probability that there will not be more than 1 failure during a particular week. Let me repeat, the question is, it is a question in the engineering field, that is in the electricity power failure aspect. If electricity power failures occur according to a Poisson distribution, from the previous knowledge, while we are identifying the model, we can model that particular experiment as a Poisson model, Poisson distribution model, and if electricity power failures occur according to Poisson distribution with an average of 3 failures every 20 weeks. Calculate the probability that there will not be more than one failure. There will not be more than one failure during a particular week. So, what actually we are, there will not be, the question is there will not be more than one failure during a particular week. That is, suppose x is the number of failures. Suppose we are defining x as number of failures. The question is there will not be more than one failure. There will not be more than one failure means x, there will not be more than one failure. So, that means probability that x less than or equal to 1. That is actually probability of x is equal to 0 plus probability of x is equal to 1. So, in order to calculate the probability of probability that there will not be more than one failure during a particular week, our problem is to find the probability of x is equal to 0 plus probability of x is equal to 1 if we define x as the number of failures. And how this probability value is obtained? This value is obtained by assuming that this model is Poisson model, Poisson distribution, and in order to find the probabilities using the Poisson model, we need what? Lambda. What is lambda? Lambda is taken as the average value. It is the mean of the distribution actually, and that is you are given that average 3 failures occur in every 20 weeks. So, that is you are given lambda is average occurrence 3 in 20 weeks. So, that is lambda is equal to 3 divided by 20. So, average occurrence of failures is given to you. If it is, what is the probability? The probability required, that is probability of, actually the probability of x less than or equal to 1 we are calculating. That is already I mentioned, that is equal to probability of x is equal to 0 plus probability of x is equal to 1. Okay. And what is the situation? This is a Poisson model. If it is a Poisson model, what is the probability mass function? Probability of x is equal to x, that is equal to e power minus lambda power x divided by x factorial, where x is equal to 0, 1, 2, etc. This is the Poisson model probability mass function. Just substitute these values here. This is probability of x is equal to 0, that is e power minus lambda. Lambda is given as 3 divided by 20. You can find that is e power minus 3 by 20 or e power minus 3 by 20. You can find the value from the table or from the calculator. You can obtain that value plus e power minus 3 by 20 into lambda power x. Lambda power means 3 by 20 all power x, that is 1 divided by 1 factorial. So, that is we have the value e power minus 3 by 20 plus e power minus 3 by 20 into 3 by 20. This probability value is our probability of not more than one failure occur in a week, that is probability of x less than or equal to 1. So, that is we are using the Poisson distribution model to find the probability of certain event, the probability of the required event using the Poisson distribution. Now, you consider another example. If the probability of a defective bolt is 0.02, find the mean, the standard deviation for the number of defective bolts in a total of 300 bolts using binomial and Poisson approximation. So, this is a question actually to find the mean and standard deviation for the number of defective boards. So, the question here is, if the probability of a defective bolt is 0.02, so you are given the probability of occurrence of a defective item, that is 0.02. So, you are given probability of occurrence of a defective item, that is 0.02. This is given to you. And what is given to you? You have to find the mean and standard deviation. For what type of experiment? You are actually manufacturing 300 boards. So, n is equal to 300. So, 300 boards are available to you, and out of this 300 boards, you have to find the mean and standard deviation of number of defective boards. So, let us define x, the random variable x, as number of defective boards. Or defective item. Suppose x is the number of defective item, and if x is the number of defective item, here also you just look the value, probability is 0.02, you can treat that value as a very small number. Comparing the size n value is large. So, use the Poisson approximation, and we can do this problem using the binomial distribution also. So, if we are using the binomial distribution, this is, we have the x follows binomial with NP. So, f of x, that is probability of x is equal to x, is NCx p power x q power n minus x, x is equal to 0, 1, 2, etc. up to n, and p plus q is equal to 1. That is our probability mass function of binomial random variable. And if we are using the Poisson approximation, our probability mass function is e power minus lambda, lambda power x divided by x factorial, where lambda is our value NP. So, this is a problem, or this is a situation where we can apply Poisson, we can use the Poisson approximation to find the probabilities or whatever be the quantities required, or we can use the binomial distribution also. So, the question here is, what is the mean and standard deviation for the number of defective boards? So, just look what is the mean and standard deviation. Suppose x is a binomial random variable, we derived the mean as expectation of x is equal to NP, and that is equal to n is 300 and p is 0.02. So, that is 6. Similarly, variance of x is NPQ, and that is substituting here 300 into 0.02 into q is 0.98. So, that is equal to 0.98 into 6. So, this is already we have the value 6 into 0.98, that is 5.94. So, what is the standard deviation? Standard deviation of this, square root of variance of x or square root of 5.94. So, this is the way we are calculating mean and variance of that particular situation, particular experiment, particular random variable, if we are assuming that random variable follows binomial. Suppose we are using the Poisson approximation. X follows Poisson with lambda, and lambda already we have the value NP, that is obtained as 6. And for a Poisson random variable, we know mean is equal to lambda, expectation of x is equal to lambda, and so this is 6. And for the Poisson random variable, variance is equal to also, that is also lambda, that is again 6. So standard deviation is equal to square root of 6. So this is the standard deviation and this is the mean of the random variable if we are assuming Poisson distribution. But if we are assuming the binomial situation, the mean is equal to 6 and standard deviation is equal to this one. So this is a problem where we are finding quantities, mean, variance or moment generative function or something like that, or probability of certain events using binomial distribution or using the Poisson approximation. And then another example again regarding the Poisson distribution, that is discussed. Suppose patients arrive randomly and independently at an OP counter of a hospital. So this is a situation that we are facing in a hospital. Suppose patients arrive randomly and independently at an OP counter of a hospital, and let the average number of patients arrive in between 10 a.m. to 11 a.m. is 6. Similarly, the average number of patients between 11 a.m. to 12 noon is 8. Find the probability that more than 11 patients come in between 10 a.m. to 12 noon. So the problem is, in between 10 a.m. to 11 a.m. average number of patients is given to you, and in between 11 a.m. to 12 noon the average number of patients is given to you, and patients are arriving the OP counter independently and randomly. If it is, you find the probability that more than 11 patients come in between 10 a.m. to 12 noon. So this is a situation where we have suppose we have the situation 10 a.m. to 11 and 11 to 12. This is it, and they are independent. The average number of patients arrive here. See, average number of patients arrive here is in 10 a.m. to 11 a.m. is 6. 6. Okay. And in between 11 a.m. to 12 noon is 8. It is 8. Okay. And the question is again is with regard to total time, that is 10 to 12. 10 to 12. The question is, what is the probability that more than 11 patients come in between 10 a.m. to 12 noon? So that means we have to find more than 12 patients, more than 11 patients. Is it more than, let me see, yeah, more than 11 patients in between 10 to 12. So what is the probability of this? So here what we are doing, this is average number of patients. Suppose you just look, this x is the random variable defined number of patients arrive in between 10 to 11, and we can treat that number of patients in between 10 to 11, and we can treat that x as a Poisson random variable with the parameter lambda. What is lambda? Average number of patients arrive, and what is that? 6. So x follows P6. Similarly, y you represent as number of patients between 11 to 12. And then Y is treated as Poisson with the average number of patients in that case is 8. So, total number of patients in between 10 to 12 can be treated as X plus Y. So, suppose Z is defined as X plus Y. The problem is actually probability of Z more than 11 patients, Z greater than 11. This is the problem actually. So, let me repeat the given situation. Suppose you have the X as number of patients in between 10 and 11, then that X follows Poisson with the average number of patients, that is 6. This is 6. And suppose Y is the number of patients in between 11 to 12, then Y follows Poisson with the average number of patients in between 11 and 12 is given to you as 8. So, it is Poisson with 8. And since these are independent, the sum X plus Y follows actually Poisson with the sum of parameters 8 plus 6. You know the additive property of the Poisson random variable. Since X and Y are independent Poisson random variables, X plus Y follows Poisson with the sum of parameters, that is 8 plus 6, that is 40. So, come to the problem, probability of Z greater than 11, this is Z is equal to 12 to infinity, that is up this is e power minus lambda, that is 14 power Z divided by Z factorial. Okay. So, that is the probability of Z, the probability that in between 10 to 12, the number of patients arrive is greater than 11, more than 11 patients. So, that is we are calculating this value. So, suppose this is up to actually it is up to infinity. So, using the Poisson table we can find that value directly. So, this is a problem where we are applying Poisson distribution to find the probability of certain event. Now, let us consider a new problem where we are applying Poisson distribution. A distributor of bean seeds determines from extensive tests that 5% of large batch of seeds will not germinate. So, from the previous knowledge, he identified that 5% of seeds in the large batch of seeds will not germinate. And the distributor sells the seeds in a packet of 200 and guarantees 90% germination. Determine the probability that a particular packet will violate guarantee. So, the question here is we have to find the probability that a particular packet containing 200 seeds violate the guarantee. So, violate the guarantee means what is the guarantee of the distributor? 90% of the seeds will germinate. 90% means more than 90% also it is a guaranteed quality. So, guarantee will violate if less than 90% seeds germinate. Suppose you have X number of seeds that are not germinated. So, let us define like this, X is the number of seeds that are not germinated. So, that means, and you are given that probability of the seeds will not germinate, 5% of seeds will not germinate. That means 5% of seeds will not germinate means P is given as 5 divided by 100. And distributor sells the seeds in a packet of 200. So, you are given n is equal to 200. So, here you can have the NP value that is equal to 500 divided by 500, 5 divided by 100 into 200, that is 10. So, multiplying you will get the NP value 10. And let us approximate this case as a Poisson distribution case. So, lambda is equal to NP is equal to 10. So, for this particular problem, you are given that probability of the seeds will not germinate as 5 out of 5%, that is 5 divided by 100. And the distributor selling the seeds in a packet of 200. So, n is equal to 200. So, NP you find that is equal to 10. So, lambda is equal to NP. If it is, if you are using the Poisson approximation, x follows Poisson with lambda, and that is probability that x is equal to x is equal to e power minus lambda, lambda power x divided by x factorial, and that is e power minus 10, lambda is here 10, 10 power x divided by x factorial. So, that is our probability mass function. Now, the problem is what actually? You just look the problem as if he sells the seeds in a packet of 200 and guarantees 90% germination, determine the probability that a particular packet will violate the guarantee. The probability that the particular packet will violate the guarantee means number of germination, the guarantee is number of germination 90% or more. So, if the number of seeds that are not germinate is out of 220 or more than 20, that is 90% means 180. So, more than 20 seeds are not germinating, then that packet violate the guarantee. So, that is we have to find the probability of, violate the guarantee means x greater than or equal to 21. One probability of x greater than or equal to 21, or we can have 1 minus probability of x less than or equal to 20. And that value is equal to 1 minus sigma x is equal to 0 to 20. You can find this value from the Poisson table, and that is e power minus 10, 10 power x divided by x factorial. So, this value gives us the probability that the distributor's guarantee is violated. The guarantee will violate it if that less than 90% of seeds germinate, that is x is the number of seeds that are not germinated, that means x greater than or equal to 21. 90% of 200 means 180, that is 20. More than 20 seeds will not germinate, the packet will violate the guarantee. This is the probability of getting that particular event. So, such problems we can find such probabilities in different fields, in agriculture field, in engineering field, in medical field. If the experiment or if the model is similar to a probability, Poisson probability model, we can find the probability values using this type of numerical exercises. So, this type of problems we can work out using the Poisson distribution. So, with this, let me conclude this session here. So, more problems with regard to Poisson distribution will be discussed in the next module. Thank you for hearing this session. Thank you to all.